So there's a direct link in between the quality of soil to the quality of the produce. And in terms of being able to head more in that direction of healthy soil, healthy food, how can we get away from a kind of universally average applied nutritional label to all carrots? And should it be like, well, our carrots have, should it be each farm starts to create their own nutritional label, and then that starts to, people start to educate the consumer about the supply chain and how actually there can be different types of carrots, and those are the low nutrition ones and these ones are higher? Is that where we should be heading, and increasing transparency on that side?
I mean, do you want to talk a bit about
Yeah.
Audacious? You go and I'll join in.
Yeah, well, that one. Well, we've invested in a company that is doing many of the things that you've just described. Right. So they're leveraging on the ground data, if you like. So they're taking samples of food from specific farms in specific supply chains, right, and analysing those foods, and then they're benchmarking those against how those farms are managed and how that food is produced. And they're providing a service to brands that are already on the path towards regenerative agriculture, or have already have been pioneering and adopted those practices for many years. And so they have a sense that their produce is of high quality. Well, they probably know that their produce is of high quality, but now they're looking to, on the marketing side, be able to translate that to their consumers.
Right. So the data side is probably a huge part of that, and I guess that would bring in AI and
exactly
as well, all of that.
And we're still pretty limited. You know, you think we've only taxonomized, they say 2% of what's in our soils. We think it's probably less. And even once you've taxonomized what's in the actual soil, let alone the food that's grown in the soil, you still need to understand how it interrelates with each other over the course of a day, a week, a season, a year. And so data is going to, until that data is understood and feeding back to us, we're not going to have a full understanding of how growing and therefore eating and eventually our health relate.
So you mean like in terms of the content of the soil, what sort of bacteria, like microorganisms, etc., all that stuff needs to be looked at because it's all playing a part in the ecosystem of the soil, which then
yes
feeds in with
but we do know some things.
Yeah.
So we do know that, for example, most agricultural soils that are used to grow crops have a fundamental imbalance, i.e. they're bacterially dominant, right, and they're lacking in fungal microbes. Now, natural soils and healthy soils have a balance between fungal and bacterial communities, and that plays an important function in making minerals available to plants, right, which is critical for their immune systems, but it's also critical for the nutritional quality that we derive from those crops. So in industrial farming, we tend to destroy those fungal microbes. Once you've destroyed them, you break a symbiotic relationship. The symbiotic relationship is that plants exudate sugars as a pathway from photosynthesis. So they use CO2 to produce carbohydrates via photosynthesis, but they dump some of those sugars through their roots, which are porous, to bacteria. Those bacteria consume the sugars and exchange back to the plant vital nutrients that have been mined in the soil by fungal microbes.
Right.
So the fungal microbes will actually penetrate into the bedrock of the soil, right, and will actually break up mineral particles and make them available at the root zone to plants via this interaction with bacteria.
Right. So it's a whole team effort. That's what I think is very misunderstood in the mainstream. That's something which people, especially when you have these farms that are using a lot of chemicals, they're like using fungicides, pesticides, etc. They're just trying to kill everything else to try to just leave whatever crop they're trying to grow, and they ignore all of that, right? They're almost not taking that into account. But then how much of this is known by the average farmer? Well,
some of it is very much experienced by the farmer. So there is a visible proxy. So compaction would be one example. And in this bad weather that we've got at the moment, huge amounts of pooling, so water that's just stuck, in puddles, trapped on the landscape, and it's not infiltrating. So those management practices that have used, for example, fungicides, have destroyed those biological communities, and the soil has basically collapsed on top of itself.
So by having having those communities grow, it aerates the soil, creates more space in it, allows it to hold water better.
Yes.
Things like that.
So one conceptualization which is very useful about what healthy soil is like is it's like a cake, a spongy cake. Okay. So it's full of air and it's full of porosity, and it has a maximal ability to absorb and infiltrate water and nutrients, and oxygen can infiltrate it. And healthy soil it's like flour,
Right.
is perhaps one way of thinking of it. It's both denuded of life, but it also can't absorb the water and it can't absorb the nutrients. In fact, those nutrients and those waters run off the landscape and go straight into our riparians and then out to sea.
And I mean, this is really touching upon like the core of why we're doing this, and why we think what we're doing is needs to have the drum banged as loudly as possible. If you increase soil organic matter, you make your soil healthier by better farming practices, which might be cover cropping and not ploughing, and reducing or completely getting rid of chemical inputs, introducing livestock, ideally having sensible rotations, the kind of main pillars of what might be termed regenerative farming. You're holding water in the landscape more. So carbon itself is hydrophilic, but also the structure of this more cake-like soil becomes more amenable to keeping water in it, whether it's the holes made by where earthworms have been, as an example, acting like holes in the cake, allowing water to flow through, or whether it's much more microscopic in terms of bacteria moving around and having pockets of air that water can come through. But the point is, it creates, it holds water in the landscape, and I think it's 25,000 litres per 1% uptick in soil organic matter per acre that can be held in the landscape as opposed to rushing off. And it creates a small water cycle. And a small water cycle is transpiration, is water coming off the land and obviously forming in clouds usually, which also are white, bounce heat back, and eventually precipitate, cause rain. That could be half an acre. Equally, that could be continent scale.
Right.
And so what we're trying to show the average LP investor that might be looking at climate is that soil is this enormous lever to pull in terms of cooling the planet,
Right.
and in terms of restoring rain and restoring weather. And there's a sort of common misconception that rain really only likes areas that are so far from a coast, because most of the rain comes from the seas and eventually gets dropped on the land, and then you have sort of dry clouds coming further in. That's just simply not true. The Sahara was a thriving savanna at points, and there are wonderful archaeological findings showing very complex civilizations in the middle of the Sahara that survived off plentiful rainfall. And what we're, I suppose, trying to do is use that restoration of the water cycle piece combined with healthy soils being the only way to ultimately produce healthy food, which makes a healthy human, which is the solution to the health crisis in our eyes in terms of preventative medicine.